Welcome back to our channel Mechline Design. In the series of engineering drawing and engineering design related videos, our next topic is GD&T fundamentals, geometric dimensioning and tolerancing fundamentals. You already know that this topic is very much important for a fresher and a person who is in the intermediate phase of his career. First of all, we need to understand that what is GD&T. A symbolic engineering language used to define the allowable variation in a part geometry. See, I'm not like going to tell you a small detail like GD&T is geometric dimensioning and tolerancing. The full form is this and that. We are directly coming to the industrial application of the team. Now, you must have seen this kind of symbols, this kind of uh, thing on the different drawings in your day-to-day life. Then, how do you going to read those things? Is the topic that we are dealing today. It is very important topic for the engineering designer because he is going to refer these kind of drawing day to day life. Also, it is very important topic for the interview phase also. Now, why the GD&Ts are used? First of all, we need to understand this, the importance of GD&T. See, if this is my final product and I make a drawing something like this, so I'm giving the whole dia and this flange dia, this outer dia, these thicknesses. So even after giving these dias, and if the QC will check this final product with the help of this engineering drawing, he may say that all the dimensions are same, and that's why I need to pass the product. But the physical, but you know that this is not the accurate product that you need. It has some bending. Now, how will you show the bending to the QC person that he may reject the file? And there comes the role of GD&T. So it improves the quality, reduces the scrap, ensure the interchangeability. So if I'm not like pointing out the perpendicularity between these two phases, initially it is coming this way. Uh, Later on in the other product, it may come in this way. So and we cannot reject it because it is like passing all the dimensions that are given. That's why the interchangeability comes into play when we focus on the GD&T. And it also lowers the manufacturing cost because it reduces the rejection. Now, we will discuss about the traditional dimensioning versus GD&T. So the comparison of the limitation of conventional tolerancing and the advantages of GD&T is shown in this figure. See, if I am going to give only the traditional dimensions, I will give the sizes, these three sizes. But again, it is not necessary that it will come to a something like square like this. It may come parallelogram, and again we have to accept it also because it fulfills our dimensions. That's why I give the geometric dimensioning also. Like the first I have put A as a datum, and I propose that these two phases are parallel with a range of 0.05 mm, and then this A becomes the datum for the condition that this phase B is perpendicular into the range of 0.067. Also, this phase C is in perpendicularity of 0.75 mm with respect to A and B. So these are the dimensions which comes under the GD&T, which helps to have an perfect part and not this kind of bulge as shown in the previous slide. Now we will discuss about the five categories of GD&T, and this is the most like repeated question of any interviewer, especially you are at the beginning stage of your engineering design career. The five types of tolerances are form, profile, orientation, location, and runout. In form, there could be straightness, flatness, circularity, cylindricity. In profile, there can be profile of a line and surface. In orientation, there can be angularity, perpendicularity, parallelism. In location, there can be position, concentricity, symmetry. In the runout, it can be circular runout or total runout. So just a small definition of each. Straightness means the surface should be straight. There should be no irregularities on the surface. The flatness, if the straightness is the line property, the flatness is the surface property. Whole surface should be plane. The circularity, it should be a circular shaft, not the oval that just I made. Cylindricity, again, if the circularity is the line property, that means it is on a plane only, right? Then the whole cylindrical surface shows the cylindricity. Profile, again, the profile of a line to a profile of a surface. Orientation, angularity, these two should maintain the angle of 30 degrees, and these should maintain the angle of 30 degrees. Perpendicularity, again, as I've just shown here, so these two faces should be perpendicular to each other. These two faces should be parallel to each other, right? And then we have position. Then, for example, this hole, this should be in the position range of 0.141 mm with respect to A, B, and C. So it should not go like this. So, like, these are the characteristics that we constrained with the help of the following symbols. Cylindricity, sorry, concentricity, that means two hole and the shaft should be concentric. Symmetry, if there is two surface and I have a square shaft, then that should be symmetric between these two. Circular runout and total runout are these runout of these surfaces that we discuss with the help of runout of the surfaces that we discuss with the help of go and no go gauges. Moving on, GD&T symbol chart. We just discussed all the symbols here only. So we move on to the next slide. This is GD&T symbol. We just discussed about these things that comes into the five characteristics. I just repeated the slide because this is very important. You can take a screenshot of this summary of GD&T symbols that will help you when you will be going to discuss about the GD&T in your interviews. I again repeat that this is one of the very favorite topics of a interviewee, especially when you are a fresher or at very initial stage of your career. Now we have discussed about these things, and I have also told you about the datum. As not that much detail, but give I have already given you a brief introduction about the datum. But what are these symbols? M, L, S, P, or free, no tolerance. We will discuss about this information also in the future slides in this video. So the complete feature control frame is this. Now, as the initial stage, I have shown you this thing now. So now you will be able to read, as I promised. Now you will be able to read this GD&T symbols here. So this is the symbol, geometric symbol that we have just discussed. This is the tolerance value. This is the feature control that I'm going to tell you in the following slides. And these are datum references. Now you can read these um, feature control frame. Now, understanding the datums. The datum can be primary, secondary, or tertiary. The functional surfaces should be selected as datum. ये important line है. The functional surfaces should be selected. The basic dimension is a theoretical exact dimension shown inside the box. The basic dimension is the theoretical dimension. This dia of 0.2 mm is a theoretical dimension. So as this is a 3D surface, then these three could be a datum. Now, why three datums? We already know about the degree of freedom, that there are six ways to free a part to move in space. These three axes, so linear motion in these three axes, and the rotational motion in these three axes. So six ways. So in order to fix any object into the space, we need to give a fixed like value of these six constraints. So that's why three surfaces. If I fix the three surfaces, then we fix the object. So the constraint are, if I give only one primary datum, then it would be 3 degree of freedom. If I give the secondary also, then only 2 degree of freedom. And if I give the three tertiary surface also, then there would be only 1 degree of freedom. So all the degree of freedom of constraints are 6. So we just discussed about this feature control frame. Now, common example of datum. For a planar surface, we give it the surface. We can give the axis of the hole. We can give the axis of cylinder. We can give point as a frame of reference or datum. We can give the slot center also. So the important thing is the GD&T are provided as a common reference. It ensures the part assembled correctly. So as just discussed that the functional surface should be the datum, then the part would assemble correctly. You give uh, that these two surfaces should be perpendicular to each other. One would be the datum, another would be the reference. Another would be perpendicular to the datum or the reference. Then it would assemble properly. Next is the control frame. It also controls the orientation, location, and runout. As I told you that this control the form, orientation, location, and the runout. So these, as I told you, form, orientation, location, runout. So this datum controls this. Make the GD&T meaningful and measurable. It also make it meaningful. Like if I say that these two surfaces are parallel to each other, I'm giving a GD&T over this, then there would be one datum and the other which follows the parallelity. So this makes it meaningful. Now let's come to this M symbol, L symbol. So this is the GD&T modifiers, very important for an interview purpose. So this is MMC, LMC, and RFS. MMC is the maximum material condition. LMC is least material condition. RFS is regardless of the feature size. In the minimum material, sorry, the first is the maximum material condition. Most material would be there. That means most material deposit. That means the whole site should be as small as possible, and the shaft size would be as large as possible. But we discuss about the whole basis system, so we'll discuss about the whole only. So in this, the make the whole will be the smallest size. This as for 10, in the condition of MMC it is 9.8. In the condition of LMC, the whole size would increase to the largest size, then it would be the 10.2. In the RFS, or the regardless of the feature size, it can be a MMC or LMC or none. So it is none. It can be either of them. So if M is given, then you already know that the whole size would be 9.8, or as per the tolerance. And if L is given, you already know that the whole size is 10.2, or as per the tolerance given. If this is not given, then the feature can be no bonus tolerance is there. It is accepted in both ways, right? So this is the MMC or LMC that we usually see here. Material condition. So material condition gives the tolerance value in the three possible ways. Now the- it comes to GD&T inspection method, that you have given this into the drawing, and how would you measure it practically? It is measured either with the help of vernier calipers, if it is a linear distance. If it is a dia, you put the shaft over the V block and measure it with the help of screw gauge or the micrometer. If it is a position, you check the dial indicator for the position, flatness, parallelism, and go gauge and no go gauge, bore gauge and the ring gauges are used for the concentricity or the run out portion. Right now, after all this theoretical discussion about the five different forms, or um, the concentricity, parallelity, now let's just take you an practical example that I've already told you in a bit brief here. Now I'll give a practical example of that. Just focus onto this slide. Let's just have a part like this. So you make a drawing something like this. You give the dimension of 60, 80, 20, 100, and the tolerance also plus minus zero point 0.1, plus minus zero point 0.1. But that will not give you the perfect outcome of the product. As I've told you that the square is acceptable and the parallelogram is also acceptable in such a case. So you'll give this surface as a datum A, and this surface as a datum B, and then you'll like position yourself for the hole, that this whole dia of point 0.1 should be at the position with respect to A and B, right? So this is the positional tolerance, this is the tolerance value, and these are the datums that we have just discussed. A is the primary and B is the secondary. So if this GD&T comes to exact as per the part, then you will be easily insert the shaft of this into the hole, right? So this is a practical example of GD&T. Lastly, I just want to say that top GD&T interview questions, again, as in throughout the whole video, I was constantly telling you that this is the most important topic for the interview portion, especially for the freshers. They may ask about this GD&T inspection method. They may ask about the symbols, the five categories that we have discussed, the maximum material condition and the minimum material condition. I've told you about the possible questions. Now, I'm giving you my personal experience that in my early career, they have asked it to me multiple times. Specifically, the repeated question was on the basis of this MMC and LMC, because generally we learn or we like wrote about the specific symbols, the definition of these, and the categories. But we usually ignore about this M. So if the interviewee wants to know that you just learned it before the interview or you already know about it in depth, he asks about this M or L. So this is very important topic that we've just discussed. In the end, I just want you to all like, share, subscribe, and comment down below other topics that you need to know in this series of engineering drawing related topics. Till then, thank you and please subscribe to the channel.